Hi, my name is Anthony Ford. I'm with Southern Kentucky skhho, and in this video I'm going to be demonstrating how to properly install, wire, and adjust a PWM. The first step to installing your PWM is to ground pin 2. It is located between the cell ground and the accessory pin. The ground pin can be attached to any unpainted metal surface of the vehicle, because the entire vehicle is grounded to the battery. The second step to installing your PWM is to ground pin 1, the cell ground, to the negative side of the hydrogen cell. The third step of installing your PWM is to connect the accessory pin, pin 3, to the ignition wire. An ignition wire is any wire that becomes hot when the key is turned to the on position. The final step of installing your PWM is to connect the cell positive to the positive side of the battery. An inline fuse is extremely recommended within 18 inches of the battery. Your Southern Kentucky skhho PWM comes with 3 adjustable settings. From left to right, they are frequency, duty cycle, and current limit. I will be thoroughly explaining each of these and their functions. Frequency describes the number of times per second that your cell cycles on to off. In this square sine wave, we can see that the cell is cycled on at the top and off at the bottom. This is a representation of a low frequency. In a low frequency, the cell is cycled on and off less times per second than in a high frequency. This is an example of a high frequency. The next setting, duty cycle, refers to the amount of time that the cell is on compared to the amount of time that the cell is off during one cycle. A 50% duty cycle means that the cell is on 50% of the time and off 50% of the time during one cycle. A 90% duty cycle means that the cell is on 90% of the time and off 10% of the time during one cycle. Here at Southern Kentucky skhho, our PWMs are fully adjustable from 1% duty cycle to 100% duty cycle, meaning you can turn your cell completely off or completely on with the duty cycle adjustment. Okay, now I'm going to show you an example of the waves that I demonstrated earlier on our whiteboard. This is an oscilloscope, and it is used to show electronic waves. This particular wave is called a square sine wave. On the multimeter here we have our voltage from our battery. Right now we're running at 14.62 volts. This is our PWM and our hydrogen cell. As we adjust our first potentiometer frequency, you can see the frequency of our cell increases. And also, as you turn it counterclockwise, it decreases. Now your duty cycle is adjusted with your second potentiometer. You can see right now we're running at about a 50% duty cycle, meaning that the cell's on 50% of the time and off 50% of the time. Now, as we turn it counterclockwise, you see our duty cycle decreases until our cell is shut completely off. You can see our hydrogen production has stopped. And as we turn it clockwise, our duty cycle increases. You can see our cells starting to generate the hydrogen again. There's your 50% duty cycle. Here at Southern Kentucky HHO, one feature that we offer on our PWMs is full duty cycle adjustment from 1% to 100%. You notice as we start to turn our duty cycle up that our cell production increases until we reach 100% on our duty cycle. A lot of PWMs on the market, if you read into them, they're only adjustable from 5% to 95%. So you can never truly turn your cell off, and you can never have your cell at its highest possible production. Here at Southern Kentucky HHO, we do our best to bring you the highest quality hydrogen electronics available on the market. We keep many models in stock, and all models go through a series of tests and inspections before being sold to the customer. If you have any questions, you can email me at anthony@southernkentuckyhho.com, or you can check out our site at www.southernkentuckyhho.com. Thank you for viewing this video.